Hi everybody. As Kev said, I am Tech Director for Operations and Reliability at the Financial Times. But I'm actually here to talk about what I did in my previous job at the Financial Times when I was a principal engineer and in charge of the content platform. And basically, I'm here to talk about how we moved an existing large distributed microservice system to run on Kubernetes. So I think conference talks often sound like they're a journey, and you say, oh, we started out in this place, and we knew we were going, and there were some pitfalls on the way, but we made it, and it was great. But I don't think that's what it's ever really like, because you have some idea that there's a city over there paved with gold, and you think it's in that direction, but you don't actually know. And you don't ever start out from home, because basically, it's really rare to be starting completely from scratch. Even if you're doing a completely greenfields project, you only have no baggage at the very beginning of that. So you don't start from the right place, and you don't know where you're going. And the decisions you've made, the journey you've already done, has a big impact on what you can do easily. So you make decisions all the time and for the right reasons, but sometimes they come back and bite you because it's much harder for you to then make some additional change. So I work for the Financial Times, one of the world's leading news organizations, and that's how we describe ourselves. And we don't talk about ourselves as a newspaper, because most people who read the Financial Times do it online. So I'd say we're as much a technology company as we are a news company in terms of what the important things that we do. The FT has several different groups within technology, and over the last couple of years, we've moved to give those groups a lot of empowerment. They make their own decisions about the technology that they use. We don't have a separate group that says you're going to run on this platform. And what that means is that we have a lot of diversity in platforms. So we have people deploying Node to Heroku, we have people using Lambda on AWS, and we have several teams using containers, and none of them are doing it quite the same way. So I'm going to tell you about introducing Kubernetes into an existing containerized stack that had more than 150 microservices already. And because of our empowerment model, it was the development team that made the decision to do this, and the development team that did the work. So this is a really simplified view of what the FT's content platform does. It's essentially, you get content in from multiple content management systems, transform it into a common format, annotate it with things like this article is about Apple, or it mentions Tim Cook, and then we make it available via APIs. But this is what it actually looks like, and I'm not expecting you to see the detail. That's the whole point. There's 150 different microservices on here, and we really went for it. I think arguably we have too many. It's large, it's complex, and that means migration is not a small thing. So why did we even decide to introduce Kubernetes? Well, I'm going to start off by just giving a bit of history of where we started out and the direction that we'd already gone. So in late 2013, we started building this, and we built it using microservices, which is the first system at the FT that we'd done in this way. And that's because for the first time, we were able to provision VMs in minutes and do automated deployment to them. And it worked. Previous to this, the previous system got released 12 times a year. We release 2,000, 3,000 times a year now. So in terms of what Anne was talking about this morning, in terms of the speed up that you get, if you go from basically maybe 6 weeks between having an idea and being able to put it in front of people, we're talking hours now, and that is 500 times quicker. And we had to automate. You can't do something with microservices, with lots of microservices, without really investing in automation. And when we started, we deployed each service to its own VM. There's a drawback about this, which is if you're running 2 instances of a service and you're running in 2 regions and you also have a staging environment and you have a team environment, you're basically going to provision 8, 9, 10 different VMs for this service, which is just enough time to do this for it to be a bit annoying. And then it's not an efficient use of resources, because even the smallest VM, you're probably allocating far too much CPU and memory for what you're doing in a tiny microservice. So early in 2015, we started to think about containers and basically Docker. We had some Docker enthusiasts that had been going on about it for quite a while. We've been keeping an eye, and we thought, well, maybe now it's ready. It's ready for us to have a go. So the question is Docker ready for production? This is a question that gets asked a lot over a long period of time. Docker 1.0 was released in mid-2014, and it said, oh yeah, it's ready for production now. I think that's for some definition of ready. I don't think for most people you'd have used Docker at that point. Or you might have used Docker, but you probably wouldn't have used all the surrounding stuff. So in mid-2015, even people who were very successfully using Docker were arguing about all the things that needed to be done before you could use it properly. And the tooling wasn't very mature. So if you were going to run containers in production at the point we were starting to look at this, you had to be pretty happy to get down some low-level stuff and build lots of things yourself. And there's an interesting graph of the cycle that technology goes through. This comes from Simon Wardley. So you start off with things that are something to be built by experts, and then as they become more common, people start producing them as a product, and eventually they become a commodity. And it seems quite intuitive, and you can definitely think of examples. Electricity, from a long time ago, is an example of this. We don't expect to build our own power stations now. We just plug stuff in. And another example would be computing. You know, we've gone from having servers in-house to our own data centers to the cloud. It's commodity now. So at the point we were looking at this in mid-2015, there really wasn't something we could just take and use. And we'd evaluated Kubernetes at this point, but we decided not to use it. We didn't think it was ready. We thought we could do something better by cobbling together some other stuff. We were running on CoreOS Container Linux, running our containers as services using systemd service files and using Fleet to do cluster-aware management of that. And then we wrote other components ourselves, normally as little Go services that did particular things. So the question is, why did we do it then? Why didn't we wait until something more mature came along? And it's an interesting question, because I really agree with this blog post from Dan McKinley, who worked at Etsy, which is, you should generally choose boring technology. And boring technology, it doesn't mean bad. It means things that the capabilities are well understood. New and innovative stuff, you don't understand the capabilities, and you particularly don't understand the failure modes. When it goes wrong, you are almost always looking at it thinking, I have no idea how to fix this. So, Postgres is boring, Varnish is boring, but people use them successfully. And if you have a problem, you can find out how other people have solved the same problem. Related to this, Etsy talk about innovation tokens, the idea being you can do innovative things, but you don't want to do too many at once. So you probably ought to think about having a couple of tokens in your pocket. What are you going to spend them on? Are you going to spend them on writing a cluster orchestrator, or are you going to spend them on something that actually is core to your business? But actually for us, doing this gave us an 80% reduction in our EC2 costs, which is significant enough to consider taking the pain of doing it. And it was many fewer steps for us to run a new service in production. And with the number of services we were writing, if you save a couple of hours for each of those, it's significant, it adds up. But there are pros and cons. The gains we got were offset by other stuff. So supportability of something you write yourself is a challenge. If you build it, you've nowhere else to go for help. And generally speaking, the documentation of stuff that you built is much worse than the documentation of something that you buy. It's missing. You don't know why the decisions were made the way they were. And in our case, most of the containerization work was done by a core group of developers who were very enthusiastic about it, and they all left in the space of about 2 months in the middle of 2016. So when that happens, you're supporting stuff that you didn't write, and you didn't make the decisions, and it's a little bit scary for anyone that's on the hook for being called at 2 in the morning. And there were limitations of the platform. We were using pretty complicated host-based routing that people didn't understand, and it was particularly hard to debug. Our deployment was done through a custom deployer. We had a very elegant mechanism for deploying changes. Very elegant, but very hard to debug again. So it was true technical debt in that we had decided to pay the interest on it because we got a benefit, but eventually it just gets a bit tiring to keep having to deal with that kind of stuff. And by 2016, tools were maturing. You heard stories about people successfully using cluster orchestrators in production. And so you could think, oh yeah, it's definitely moving through this curve. It's getting towards the fact where there are products that I can just buy. And actually, when that happens, you should probably jump onto it. Don't keep maintaining your own cluster orchestrator unless you're planning to actually sell it to other people. We are not a cluster orchestrator company. We are a news organization. So as soon as we can get back to focusing on innovating in that area, the better. So late 2016, we had a workshop and evaluated a few alternatives. And we talked about what our goals were going to be. So there were some obvious goals. We want to get rid of the stuff that we wrote ourselves. We want to make the routing much more simple. We wanted better load balancing, because Fleet would cope with moving services to a new VM if you lost a VM, but it wouldn't move things around if you started to get all of your services running on only one of the VMs. So we wanted better balancing of load. And we wanted to feel that we could basically shut down a machine and know that it would automatically come back up and the services would all be fine. And we didn't know that before. We also talked about the metrics of how we'd know whether we had succeeded. And one of them was the amount of time that we would spend as a group keeping the cluster healthy. So we had a couple of our developers across probably 20 developers who would be keeping an eye out for, is this stuff working, has something just alerted? And the second thing is genuine. The number of times that someone's putting eye roll emoji into Slack about this, saying, oh, container stack's fallen over again. It's a good way of measuring if you're succeeding in making people's lives better as developers, because they will moan in Slack, even if they won't tell you in person. We chose Kubernetes over the alternatives. We looked at ECS. We thought that, like a lot of AWS stuff, obviously had a lot of features, a bit harder to understand how to get going immediately. And we had a feeling that more people were using Kubernetes, and that we were kind of hoping that it would become, it seemed like it was an emerging standard. And I think the announcement of EKS was a nice confirmation that, yeah, we were probably right there. And after we'd made the decision, I saw this poll, and I thought, yeah, this is good. Other people are using this. That means I can basically Google, and someone else will probably have hit most of the problems that we're going to find. February 2017, CoreOS announced that they were getting rid of Fleet, and we had a year to basically replace that. And that was okay. We thought that at the time, it felt like quite a long way off in the future, and the best thing was, we had to migrate, but we'd already made the decision. So we weren't being pushed into it by a bombshell of, oh yeah, we're getting rid of the thing that you're running on. It was, no, we've already made this decision. But I kind of want to say that, and I think this relates to some of the stuff that Anne was saying earlier, and Ian, is actually, if you're using leading edge technologies, you have to be comfortable that sometimes they won't work for you and that you might have to go back and change it. So, we get a lot of benefits from adopting these things. So we'd saved a lot of costs by going to containers early, doing microservices. We were able to get things out much more quickly, but the development team spent a larger amount of the time than they would like just making sure this all worked, or building tooling, or all the stuff around the edge. You're paying a cost, and at some point you should look around and see, do I need to say this is too much of a cost and I should change to something else? And you should expect to do that. And over the last 4 years, my team's also migrated from Java to Go. We've migrated from a proprietary RDF store to Neo4j, and these have all been driven by operational concerns. Can we actually operate this in production, or are we really scared that it'll just fall over in the middle of the night and we won't know what's going on? And you shouldn't be too scared about making the wrong decision. And I'm going to also quote Jeff Bezos in his letters to shareholders. But he basically talked about, a couple of years ago, about there are two types of decision. Type 1 is not reversible, and you should be very careful about making them. So probably Article 50 is a type 1 decision. Once it's done, very, very hard to reverse it. But type 2 is like walking through a door. You can always go back out. And Bezos says that we tend to treat everything as though it's type 1, and we go through a heavyweight decision-making process. But actually, you don't need to. If you can reverse it, then just go for it, and just be willing to go back and change your mind. But you do need to understand what you think you're going to get out of doing a migration like we did to introduce Kubernetes. And it's still a major challenge. You don't really want to be changing your platform while you're operating a live system. At the start of this migration, we had 150 services. They were running live, and they were under active development. And when I say active development, this was our attempt to map out the different work that was going on this platform in 2017. Again, you probably won't see the detail, but there are dependencies going multiple ways between different teams' work. It was complicated, and the migration team had to somehow migrate the platform while all of this was going on. It was quite hard for us to think about building a meaningful, minimum viable platform. And if you're basically going, oh, we're going to use containers for the first time, you can set something up that's quite small, deploy a few services. But all the things we were interested to know if we could get from moving to Kubernetes, we kind of needed a lot of things there to do it. It was all complicated stuff like routing or failover. So we started off by thinking we won't have to run in parallel for that long, but it was really obvious that that wasn't true. And in fact, I calculated that we did well over 2,000 code releases while we were running at least part of the stack in parallel. And if you imagine that doing it in parallel adds 10 minutes to each of your releases, that's actually nearly 50 working days extra work because you're running it in parallel. So these things quickly mount up. The scale of running lots of things, lots of releases, a tiny overhead for each one is huge. We also created over 100 new repositories last year, and they're not all new services. Some of them are rewrites, some of them are other things, but there's a lot of new services, and because we're running in parallel, we have to make them work on both stacks. It's extra work to do that. And once we realized we were going to be running in parallel, deploying to 2 stacks, we had a lot of decisions to make. So the first thing was, are we going to try and run separate branches for the 2? We started off by having a branch for the work for Kubernetes, but I never want to go back to that merge hell where you used to try and put all of your changes that had been done in 2 different branches together after a couple of weeks. This was going to be like that, but much, much worse. Your choice is to just get really far apart or to spend your life merging stuff that you don't understand because someone else was doing it. So we basically went, okay, we are in fact going to put everything on master, and it's going to go to both places. It's going to be deployed live and to the new stack. But that means that you are putting releases out into your live stack purely because of the changes you're making for your new stack. So there's a risk. There's a risk of doing that as well. But it does mean you've got a single Docker image, you know what version you've got, and you can put it out there. The next decision then is, how do you do the deployment to the 2? Because if you have completely separate deployment mechanisms, you will end up with someone forgetting to put one of the releases into one of your stacks. And if you've got 150 services, you actually can't just scan and see, obviously, that that's happened. But you don't want it to be double the effort to do the deployment, and you especially don't want to find that you can't put out a change to your live environment because something went wrong with your experimental stack that you're still working on. So in the end, we kind of took a midpoint. So it was part of the same process in that if you tagged releases in GitHub, which is how we tag things to go into the old stack, it would start the process to go onto the Kubernetes as well. And we also wrote a utility. We wrote a program that we could run across both, and we'd see anything that hadn't been released in both. And we were going to basically automate it, but in fact, there was just one poor developer who basically spent a year running this every morning and going, you haven't deployed this, please fix it up. And it was never quite, it was like that thing with that XKCD cartoon about automation. It's never quite worth spending the time to automate it, but I don't think that he really enjoyed that. And you have to think about testing, because you don't want to have to test twice for everything, but you have to take a risk-based approach. You have to decide what level of risk you're comfortable with. So we went, okay, we really care about our live stack. So that's where we do our testing. But we lent a lot on automation. So automation and sort of synthetic monitoring. So we already had the ability to send all of our live publishes to any other stack. We do it for testing and staging, so we just did it for our Kubernetes stack too. So we basically had the same publishers of content going through, and we were able to replicate load from our live stack also to the new stack. So you basically could tell whether it could deal with the kind of load and the kind of requests that were coming in for real. And that could pick up quite a lot of things that would maybe have been picked up by manual testing if we'd done that. And then we just did some end-to-end testing towards the end. But the real lesson of this whole thing for me is that doing anything 150 times takes a really long time. Even if you think that you're going to spend 30 minutes a service, that's 10 days. So any task that we were doing as part of this migration that we had to touch every single service, that's 10 working days. But the changes per service weren't that big. So we basically used Helm for deployment, migrating from systemd service files to Helm charts. And they were pretty standard, and that was not a difficult change to make. We also integrated all these services into a templated Jenkins pipeline. Again, small changes per service. We were changing our deployment mechanism to make it more easy for people to understand that they were deploying a version to an environment. So those are not huge changes, and that was the majority of the service-specific changes that we actually needed to do. And it was good to get everyone involved. So we had a couple of days, we called them Helm Day. Everyone's going to come in from every team that's working on this platform, and we're going to basically do some migration. Got everybody involved. It has a hit on all of your other commitments that you have, but our product owner understood, and we wanted people to feel positive about this and not feel it had been imposed on them by a small subgroup within the team. But actually, what we discovered as part of doing this was a lot of things that were kind of broken in ways that we didn't understand beforehand. So your code always has bits of the code base that change a lot and other bits that don't. In a microservice world, the way it manifests itself is you'll have some services that you haven't deployed for several years, potentially. They've just been sitting there doing their job. Now we needed to basically build and deploy them. And you can get hit with some really unexpected problems in that case, particularly if you use Go, because prior to version 1.5, and most of these were quite old, there was no dependency management, and unless you were using vendoring, which was introduced in 1.5, every time you build it, you get the latest version of all the libraries that you use. So pretty much, if you leave it for a year and a half and you build it, it will be broken. So that meant we introduced vendoring. Actually, that improves our Go apps considerably, but it's more than half an hour's work potentially to get that right, particularly if you have, the problem we had was that one of the libraries we used pretty heavily had changed case of its import statements, and basically this caused us an enormous amount of pain. We have a health check standard at the FT, which actually is very useful generally. We can go to any service and say, tell me about your health. And there's a well-formed response, and we have a service that aggregates this together and reports on it. And we rebuilt it for the Kubernetes stack, so we could look at things at the service level, but then we could dig into the pods. Unfortunately, we rebuilt this service assuming that we had actually complied completely with our health check standard, and it turns out we hadn't. There were lots of services that didn't obey the timeouts, so they basically wouldn't time out correctly, and as a result, we'd get things reported that they were not working when in fact they were. So you can fix it, and it is, again, it's improving your code base, but it wasn't what you were expecting to do as part of the migration. Similarly with liveness and readiness probes. So with Kubernetes, there's a liveness check that says, do I need to basically restart the service? So we did a TCP check for that. And there's a readiness check that says, are you ready to take traffic? And we have a good to go standard at the FT. Again, great, we have a standard. No one really uses it, so it turns out lots of our services didn't have it, or it didn't work right. So it would basically say, yeah, I'm fine, when it was totally not ready. The service was totally not ready to serve requests. So again, had to make that kind of change. And then the next thing was about resource limits. So we had set memory limits in the previous stack, but because Fleet didn't move things around based on those, they weren't always great. And so although we migrated them, we sometimes had to change it. Some of our services pretty much unchanged since we wrote them at the very beginning, before they were even containerized. And 12-factor apps, there's a whole bunch of suggestions about ways to write something that will cover nicely. The thing that really got us was many of our apps expected that when they started up, the database would be there. So we had to add code in to try again, back off, retry. And we had to edit about 25% of our applications to remove the host-based routing, because we didn't need it anymore, and it was just, we had to find another way through the path. But the worst thing is, actually, it's really easy to get sucked into making things better. If you as a developer go and look at an application that you wrote when you were new to writing Go 2 years ago, you want to actually do things right. And trying to stop people from fixing up all the small things, a lot of that was just stylistic things, was really, really hard. Because that can spiral out of control, and you're just having someone saying, yeah, I'm just doing a bit of fix-up. You can't do that for 150 services, because that will take far too long. So we had that challenge, but we did basically manage to do a lot of improvements as part of this. But it would have been better, I think, if we had swarmed on the work. So we had a team working on this, a small team, for a year. Mostly because we didn't have enough funding to do this in a more big bang way, but it's very hard on that team. You know, they're basically doing repetitive tasks for all the services throughout an entire year. And the longer you run in parallel, the more overhead you're paying on the code changes. And also the higher the costs, because as soon as we're running 2 stacks in parallel, our EC2 costs went up. You want to explain that that's going to happen before someone gets a graph like this, because it's a bit of a shock to the system. But it wasn't just that. We were sending all our logs to Splunk, running 2 stacks in parallel, basically blew the license limit and got our infrastructure guys down on our heads as well. And then there's also the politics. of someone saying, well, you've been working on this for a year. It's the same cost as if you put an intense team on it for 2 weeks, but you're reporting on it and it just seems like nothing's happening. So I think it would have been a lot better for us to throw everyone at it. It's much harder to get agreement for that, but it would have been a lot better. It would have been much better if we had not tried to fix everything. And this wasn't just tidying up applications. It was basically, this project became a repository of all of the hopes and wishes of everyone in the team. What would we like to have done 2 years ago? It would have been great if we weren't using Kafka. We'd really like all our stateful services not to be in the same cluster. Yeah, that's great, but it's not the thing that gets us across the line in time for the deadline. And you have to be really forceful to stop that kind of thing from just becoming overwhelming. So, going live, how did that go? Well, we did go live just before Fleet got removed. When I say just before, technically it was after, but it was before any new Core OS updates got released, so we just about got there in time. The migration itself went very smoothly. The only problems we had were change in behavior where we fixed something where we weren't complying with the HTTP spec, and it turns out that lots of people were only working because we weren't complying with the HTTP spec. And also we discovered that we had some key integration points. What we found out were all the people who'd managed to somehow get away around those points and weren't using the URLs when we changed our DNS. They were still pointing to the old stack. So mostly we found where other people had been a bit dodgy. The results. Did we get the results we were looking for? Yeah, we did. It's a much more stable platform. So in the month following go live, we had 3 production problems, whereas we had 17 in the same period last year. We've had 2 call-outs since it went live. In both cases, by the time the developers opened up their laptop, Kubernetes has fixed it, which is considerably better than before. And we have overwhelmingly hit the metric of much less complaining in Slack. I haven't seen anyone moaning about it. And that's good. That's really nice. In fact, we are spending much less time doing support of this system. It just recovers itself. It's great, and it's just really nice for people to be able to Google. You know, we can learn from others. We can go to talks about it. We can send people on training, and that makes a big difference. And then also, I've carefully taken the numbers off this, but we were basically comparing 3-year cost of ownership for our old stack, if we'd migrated to ECS or to Kubernetes, if we'd stayed with our original approach of 1 VM per service, and also, because we had people running stuff on Heroku at the FT, if we had just moved to Heroku. And then basically, that's okay. You know, costs are comparable, stability is more, that's pretty good. So that was our journey. We didn't really get where we were planning to go, but it's kind of a nice place anyway, so we're okay with that. And we've improved a lot of things as part of doing that migration. We have a stable, more stable, cheaper system, a happier team, and we're able to focus on the things that are really important for our business rather than our platform. Thank you.